Hello friends, this is Durga again from ITversity, a one-stop shop to learn all the technologies. At this time we are talking about CCP Data Engineer certification, and as part of this video under Transform, Stage and Store, I'll be covering denormalizing data from multiple disparate data sets. So when they say denormalizing the data, typically in OLTP systems, data will be normalized. So the example for it is our retail DB data. So if you actually look for the data model, just search for Cloudera retail underscore DB, and the first link getting started with Hadoop tutorial actually have the data model. Let me see where it is. I don't think this is the one. I think this is the one. Okay, let me see. Yeah, it is exercise 1 only. So this is the data model. It is normalized. So if you are not familiar with normalization, you have to recap or review it. So normalization is used in traditional RDBMSs to reduce the redundancy, wherein we will have parent tables, child tables connected with primary key and foreign key relationships, etc. So in this case, you can see customers and departments are the parent tables, and then departments have a table called categories. Categories have a departments have a child table called categories, because a department can have multiple categories of products, and then each category will have multiple products. So categories is the parent table and products is the child table, which have one-to-one relationship. And then when the transactions actually happen, as part of the order items, we have product ID. Hence, a product can be sold as order item for multiple products. Hence, there is one-to-one relationship or parent-child relationship between products and order items. Similarly, orders are placed by customers. One customer can place many orders. Hence, customer is the parent table and orders is the child table. And now you have order items and orders. Each order can have multiple order items. Hence, order items is the child table and orders is the parent table. So when we actually process this data, on top of the orders data, there can be external data also that might creep in for your business requirement. So at times it is imperative for you to denormalize the data for the performance reasons. In Hive, you should reduce the joins as much as possible, as many as possible. You should not have many tables in the join. It is not only limited to Hive, but even in data warehousing, joins are not considered to be good. That's why we actually design our data models in data warehousing or even Hive using different concept than normalization. We use the dimensional modeling. We go with star schema and snowflake schema, etc. So it is typical that you have to denormalize the data in Hadoop. Whether you use Hive or other tool, it doesn't matter, you have to denormalize. So as part of this video for this certification item, I will try to create a table which denormalize data and store the denormalized data from these tables. So already I have created all these 6 tables. When we before actually getting into Hive, we have categories, customers, departments, order items, orders and products. Now let us define a problem statement wherein we want to get a report. The report requirement is, for each department I want to know how much revenue is generated by month. So the requirement is, for each department how much revenue is generated by month. So we need the department because we need to get the details from department, and then we have to get the revenue. Revenue is under order items. Order item subtotal will give the revenue, and we need the date, which is in orders table. So we have to join orders, order items, products, categories and departments to create this report. And if you want to do this for all the reports, then it can be overkill. Okay, for that reason, while loading itself, we denormalize the data and we load it. Hence, people can fetch the data easily by reducing the joins. So if you have to develop the query for this purpose, I will do that. So here you can see the tables, describe departments. It requires almost all the tables except customers. It has department name, ID and name, and then categories. So department ID is the parent key in departments in the original table, and categories has the category department ID, which is foreign key to department ID in departments. So categories and departments are connected using category department ID and department ID in departments. Similarly, the case with products. Products has product category ID, which is the foreign key for category ID in categories, and then order items have the product and order items have the order item product ID, which is the child key, foreign key to a product ID of the products table, and order items is also child table for orders, connected with order ID in orders table to order item order ID. So we have to join all these 5 tables to get our monthly report based on the department ID. Okay, so we need, so I will give department, I will give D for D as alias for the departments table. So D dot department ID, comma, and I want revenue from order items. OI, order items, I will refer it as OI, so I am giving it as OI here. Order item subtotal is the field which we can use to get the revenue. So I will name it as monthly revenue, and then I also want to get the month of order, month from the orders table. So for that we have to use substring function. So you have to be familiar with all these functions. You have to explore all the functions by running show functions command, and you need to get the syntax of each of the functions, how to use those things. I will try to cover as many functions as possible as part of other videos later, but for now we will be using substring function. Using substring we need to get year and month, and the order date in orders table is of format YYYY -mm -dd and then timestamp. In this case I just want year and month because I am generating the monthly report. So O dot order date, I want from first character to 7 characters, which is year hyphen and month. So 2014 -01, 2014 -02, etc. So I want 7 characters, and then month. Okay, now we have to start the join. So we have to use ASCII join. We cannot use joins like in Oracle, where we actually give table names comma separated in the from clause, like this: orders O comma so it is getting a little bit slow. Order items OI, it does not work like that. Okay, so as it is getting slow, I will try to develop this in the GitHub page itself. Okay, so it will be available to you in my GitHub account. Code is the repository, and then it has Hadoop, EW, Cloudera, Hive, and there is a file called 07, actually it will be 17. Let me do this. I have to create this again. Okay, I'm creating the file again. So 17 Hive denormalize.txt. Okay, and now instead of comma separated table list, we have to use ASCII join. Okay, so we'll start with order. So join order items OI, and the fields on which they have to be joined is OI dot order item order ID equal to O dot order ID, and we have to join with all the other tables, products, categories, and departments. And what is the table name? We have to give products P join, sorry, not end. So here it should not be end, it should be join products. So orders is directly connected with products. So P on O dot order item product ID. So order items and products are connected. If you go back to this data model, order items is connected with products based on order item product ID and product ID from products. Okay, so here equal to P dot product ID, and then join categories C on P dot product category ID equal to C dot category ID, join departments D on C dot category department ID equal to D dot department ID. And then if we have to add any filter condition, if you want to get only for 2014 or 2013, you can add where condition. So here I would like to get only for 2013, where O dot order date equal like 2013 percentage, because I want to get for all the months in 2013. And then I have to apply this aggregate function. Okay, so what we need to do is group by D dot department ID comma month. Okay, so these two are the fields which we use to group by, and let us test this. And now you can see that so there is one invalid reference for the order item product ID. We will see that it's in the 4th line. It should be OI here, not O, because order item product ID is in the order items table. You can see it here, order item product ID, and the alias which we have given for order items is OI, not O. Okay, now let us run this. Actually we will give the month also before the revenue, monthly revenue, so that it looks more meaningful when we actually look at the results. If you want to sort by, you can sort by also by using order by clause. Now it started running. Still there is so we cannot use this one directly. We have to use this function so that it can group by that function, not this one, the month, this one. This is the because we are trying to get revenue by month, we have to group by the logic o dot order date 1 to 7, which means it will fetch year and month and then group by based on that. Okay, so for denormalization or for most of the assignments, not only from the certification perspective, but also when you start working in the true environment, you have to be familiar with writing complex joins. So right now, as the CloudX lab which I am using to demonstrate this is using Hortonworks platform, it is using Tez. To avoid that and to avoid any confusion, you can set Hive execution engine to MR. Okay, and now we can actually paste this query. So now you can see the results. We got for each and every department. Here we got the department ID. If you want department name, you can change the query. It's pretty straightforward. Actually, for this query, it is better to have department name rather than department ID. So I'm changing it to department name. Now you will see the results based on department name and month. Now you can see that this query is using something called distributed cache, and it is only launching one MapReduce job. But if I disable distributed cache, which is possible if these tables are large, in that case it will actually run multiple MapReduce jobs and it will take quite a bit of time to get results for this complex query. Okay, for that reason we should denormalize and store the results in the denormalized format so that our queries runs faster. As of now, this query has taken 31.882 seconds. Now we will try to denormalize. For denormalization purpose, what we will do is we will just create table monthly, sorry, yeah, monthly revenue or daily revenue, whatever. So there is something called granularity. At what granularity you want to compute this revenue while creating this denormalized table. Let's actually keep the granularity whatever order items have at this time. So we will not change granularity. So in this case, we will say retail denormalized. Okay, we don't want to do any aggregation, we will just denormalize the table, and then we want to get all the necessary information which is required for our monthly revenue aggregations later from this denormalized table. So what all this it need only a few fields such as department name and order date and order item subtotal. Probably we might want to have all the fields from the order items just in case if you want to generate reports from other attributes of order items. So we'll get all the columns from order items. We will get order date. We will not get all the other fields from orders table, and then we will get the department ID and department name from the departments table. So I will get d dot department. Sorry, d dot star, I will get everything from departments table, I will get everything from order items table, and then I will get only order date from orders table. I don't need anything else. Okay, and then we will actually perform all the joins, and we will not filter in this while creating this denormalized table. Okay, so then we are actually performing denormalization only to avoid joins later when we want to get reports at different granularity. Okay, here we are keeping order items as is. So whatever number of rows we have in order items table, this retail denormalized also will have only those many. but we are also getting the departments associated with each order into this denormalized table along with the order date from orders table. So this is what denormalization is all about. We are actually fetching the other fields which are required for our downstream reports using this data, avoiding joins while generating the reports. Okay, so we can run this query. So there is some issue with syntax. Here we have to add as before selecting the columns from the table, and also I have specified row format delimited fields terminated by. In case if you want to review the data, it will be better readable than not specifying the delimiter. So while creating the data into the table, it will create data with pipe as the delimiter between the fields or columns. Okay, now we can run this. Okay, now it will run the map reduce job joining all the tables, and it will load the data into the retail denormalized once the data is joined and loaded into the table. So it is done. It took around 26 seconds to read the data from all those tables and get the fields which we are interested in into this retail denormalized. You can actually run describe formatted and then the table name and see the details. So this is the location where the table is created. You can actually review that if you are interested in, and here you can see the columns. It has not only order items data but also has the department ID, department name and order date. So instead of having data from one table from the normalized data model, we have denormalized and fetched all the necessary columns to generate our reports on this data. And you need to understand the concept of granularity. Here we are using the log granularity, we are not aggregating anything here. So we can actually generate reports not only at month level, you can do the reporting at day level, weekly level and yearly level. If you already aggregate while denormalizing, then you can only generate reports monthly, and they can aggregate up to yearly and at higher level, but you cannot go down to the lower level such as daily and weekly. As we have denormalized the raw data, here we can actually run our reports as per our granularity. And before actually running our report to get monthly revenue for each department, first we need to validate that we got the necessary data into this denormalized table. That you can do it by running select count query on both denormalized table and also the main table in our join condition to load into this denormalized table. And the main table is nothing but the child table, which is the order items. The counts between the two tables should match unless there is a Cartesian product somewhere, unless you mess up with the join condition or filter condition. If you are filtering the data, and the counts have to match. So you have to validate before confirming that we have got the data correctly. So select count of star from retail denormalized and hit enter. You can see there are 172,198 records. You can also run the count command on order items, and it should match exactly because we haven't filtered any data. We just use order items and join with the parent tables and got the denormalized data into this retail underscore denormalized. Hence we should have 172,198 records in that. So based on the requirement, based on the fields you need, you have to plan the denormalization and you have to load into the denormalized table. And in some cases, if you want to denormalize at higher aggregated level, at higher aggregation level, you might have to use aggregation functions also. But here I have just covered denormalization without performing any transformations or aggregations, just by joining all the related tables to fetch the columns we need. Okay, now you can actually validate the data by reading some rows. by running limit 100 and hit enter. You can see we are able to get the data. Department name is here for each and every order item. Now we can actually run this query very straightforward to get the data aggregated at month level for each department. So select department name, substring of order date 127, order month is the column name I have given, and then aggregate function to get monthly revenue, and group by department name and month. Here order date 127 because the date have year and month in the first 7 characters in the form of YYYY hyphen mm. So we will be getting YYYY hyphen mm for each and every record. So we can actually run this query. Earlier on the normalized data model, it took 36 seconds, I guess. We can scroll up a little bit here to see how long it took earlier. It took 31 seconds to get the results. Now we will see how long it will take. It will be faster as our data sets are small. It might not be that fast, but when you actually implement in the production cluster on the production volume, definitely the performance will be much better. Even with this lower data volume, we got almost 20% improvement on the query, but in actual production volume, you can get 80%, 90% depending upon the number of tables that are eliminated as part of the joins after denormalizing the data. Here in this case, it took 26 seconds. And also we will check one of the revenue for one of the record for outdoors 2013 December. The revenue is 83,084. We'll go back and see if there is any difference, and it exactly matches. So even when we run this aggregation query on the denormalized data, it still works. Okay, so that being said, this is all about about denormalization, but in some cases there might be scenarios where you have to use the other functionalities such as aggregation, filtering, sorting, etc. while denormalizing the data. You might also have to partition the data. So you have to not only learn each and every component in silos, you also should be able to connect those things to come up with a robust solution for your business problem. That being said, I hope you are enjoying the content on the channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss further about certifications or big data, please join my LinkedIn groups called ITversity-certifications or ITversity-big data. And finally, if you are not subscribed to my channel yet, please do so. And also, if you live in countries such as US and UK where fan funding and or support this channel is available, please support me so that I can come up with more and more content like this. And the way you can support is under the subscribe button. If support this channel fee or fan funding is available in your country, you will see support this channel section here. Just click on that and you can contribute whatever amount you want. Thank you. Bye.